Let's talk about optimization of z equal to f of x and y. We have three main methods for calculus 3 and a few tricks that you learn in the lab sections usually. There is the local extrema, that's the second derivative test. Then we have closed and bounded region, equivalent to closed interval method of calc 1. And that gives you the absolute max and min. And then we have the Lagrange multipliers. And so basically there is a function and you're multiplying it over a constraint basically. And so for the first one, what you want to, basically first one, you want to find the gradient vector of f, which is the f sub x and f sub y. And set that equal to 0 vector and solve for critical points. Then you want to form the discriminant, which is the f sub x x times f sub y y minus f the mixed second partial to power 2, and then if d of a and b is less than 0, at a and b is a saddle point, the function has a saddle point at a and b, if d of a and b is equal to 0, the second derivative test is inconclusive. So I can't tell whether or not a local extremo or saddle point or anything. If d of a, I mean, one of those, but I don't know which ones. And then if this is bigger than 0, if f sub x x of a and b is bigger than 0, then local min, and f sub x x of a and b is less than 0, local max. And again, we learned that if basically if d is bigger than 0 and f sub x x is bigger than 0, then f sub y y has to be bigger than 0. And we learned that if again d of a and b is bigger than 0, and f sub x x is less than 0 at a and b, then f sub y y has to be less than 0. That's just algebra. Now, so this is a method of basically categorizing the critical points. What about closed and bounded region? Closed and bounded region, you basically set the gradient again equal to 0, solve critical points. Then find all the boundaries, and make basically find critical points of boundaries, and find critical values of the boundaries. And so those critical values give critical points on boundaries, and count the endpoints and compare. What does it mean to compare? That means that you find all these points, you plug them into the original function f, and then you figure out whichever is the biggest is going to be the local max, whichever is the smallest is going to be local min. And then there's the Lagrange multipliers. In that case, you will have a z equal to f of x and y, and g of x and y equal to a constant. It turns out that the points of interest are going to be points that solve for gradient of f of x and y, equal to lambda gradient of g of x and y, and g of x and y equal to c. Okay, and so if you solve for x and y in this equations, that then this case is going to be 3 equations, you will find points of interest. And if it turns out that g of x and y is bounded, then those points of interest you can check to see which one gives you the maximum, which one's giving you the minimum. Beside being the bounded, there are other methods that you can use to find the absolute min and absolute max on a Lagrange model with a constraint problem, basically. And so you have to go problem by problem to figure those out.